So thank you, everybody. It's a real pleasure being here. So before I dive into my research and what I want to show you today, I want to share with you kind of two remarks. One is personal. It's as a Spaniard that arrived 10 years ago here, I've been really waiting for the troops. So thank you for coming with the biggest generals at the helm. So finally, you guys are here. I'm sure Paul Revere is in his way to Concord, screaming, the Spanish are coming, the Spaniards are coming. So they are here, and yes, we are. And the second remark, and it's something that Professor Venegas was telling me in one of the coffee breaks, is that the consortium has chosen a very, very unique date, a very emblematic date. This is today is October 12th, so I don't know if this is by chance or by design, but I have to say it couldn't be any better. So I think this means good karma. So, okay, now the research. May I have 2 more minutes? So or I can stop here, it's quite late. So yeah, let me tell you very briefly what we do. So my primary focus of my group is the study of COPD, and basically the study of the pathogenesis and the genetic determinants of the disease. Why COPD? 3 components. Buzzword, genetics. Everybody loves genetics. There is a strong belief there is a very strong genetic predisposition of the disease. Everybody that smokes develops COPD, but only 20% of the smokers have COPD. So, did I say that right? Yeah, no? So, okay, the other way around. I was testing your functions. So, that is an important point. The second, market size. COPD is becoming the 3rd leading cause of death. So I think as such, we have a huge health problem here with a huge healthcare utilization. Third component, market opportunity. Right now, there is not clear therapy for these patients. And it's in our best interest to develop the tools that can enable the therapy development that can stop the disease progression of these people. So, how we do this? Basically, well, just let me tell you, our group is a multidisciplinary group. There are 2 pulmonary scientists on board, as well as 3 computer scientists like me, as well as a master's student. Indeed, 2 of them are there. Sila, Teresa, could you please raise your hand? So they are really the people doing this work. Our paradigm, very similar to what Professor Malpika was showing. We want to have an end-to-end solution. We have a lot of images, so we are involved in studies with 10,000 patients. We develop our in-house image analysis techniques that give us the morphology and the components of the lung. And also what I think is the most unique, so we are in the search of the best phenotype that can give us the best clinical outcome, can give us the best phenotype for genome-wide association studies, as well as the best endpoint for the therapies that can be developed. But we do this in a 2-way street. So typically you develop the phenotype and then you give this to your statistician or to the epidemiologist to look for the gene. We want to also use the genome information in a closed loop to find the best phenotype that can characterize the disease. So I think that is kind of a unique perspective to this problem that hopefully is going to give us good results. So finally, we have developed our own platform that is open, so everybody is welcome to use that, and we are deploying that in multiple studies. And our wish list, I think we have both computer vision problems and machine learning problems that I'm sure people in the room has already solved. So please tell me in the break, because that will save me a lot of time. So our goal is to collaborate with all of you, people that have or share similar problems. Thank you very much. If you want to know more, you want to come into the lab, you are all welcome. Just shoot me an email or to George, and we will definitely be happy to accommodate your request. So thank you.
Fabulous. Thank you.